Good evening, everyone. We're so glad to have all of you here today from all parts of the country, and that too in our first production facility. I'm Aniket. I'm one of the vehicle designers here at Ultraviolette Automotive, and I welcome you to an evening that all of you have been eagerly waiting for. So without further ado, let's put our hands together for our founders, Narayan and Neeraj, on stage.
Thank you, Aniket.
So they will be taking you through what we have in store for you on our first ever battery day. And there's some exciting stuff ahead. So over to you, Narayan, and you guys have a great evening.
Thank you. Very warm welcome and good evening to one and all. Like Aniket mentioned, this is our first production facility. Honored to have all of you here. And today is a big milestone for us. And we are going to be talking, of course, about the batteries and the innovation that's happened over the last 2 years in terms of the batteries alone. But to begin with, we want to get started with a quick recap of 2019. And a lot of you had a prior experience with the motorcycles on the racetracks. We had an unveil event as well. So there's a lot that is still the same, the intent, the essence of the motorcycle, and there is a lot under the hood that has gone through significant changes and improvements. So over the next, say, 20, 30 minutes, we'll walk you through some of that, the back end of our engineering process and the design criteria that we worked with, and get to the batteries post that. Yeah. So introducing the Ultraviolette F77.
Complete control on the vehicle itself.
But this is like Tron meets Tesla.
So yes, that was a really quick recap. What happened post that is, I think, what we want to touch upon in the initial part. And getting to 2020, I think all of us are well aware what happened with the automotive industry, and most industries across the world. It was the pandemic situation, right? So we were good to go into production at that point. We had to take a hard call of, we weren't too clear on when the lockdowns are going to end, when the global situation is going to ease out for us to get back into the R&D production phase. So what we thought of at that point was there were a bunch of features that we had marked for generation 2 of the F77, which was slated to launch about 2 years after the initial version. And for us, this whole phase of about 15 months meant leapfrogging those entire advancements into what is coming out now on November 24th. So a good amount of that time went into just leapfrogging from generation 1 to generation 2. And I think a result of what you're going to experience and see through the rest of the evening is like a real consequence of imagining in India, designing in India, and of course, making in India. And yes, so first part of the design process for us. Before I get to the frame or the chassis, let me touch upon the batteries. So the batteries went through a fundamental change. We'll get to that in a lot more detail. That meant the entire frame architecture, the weight distribution, all of that had to be rethought from the drawing board stage itself. So the first criteria for us was to reduce weight on the frame because, of course, the range has gone up now. The weight of the batteries have gone up. So how do we achieve this? So the initial version of the frame ran a cradle around the motor mount. The motor mount was a suspended member within the frame. And what we got to from 2019 to 2020 was a very different architecture. So this is what is today going into production. The motor mount itself is a stress-bearing member. The frame has gone down in weight significantly. The motor mount has gone up in strength as well significantly. And in terms of some data points for you, yes, so coming to the motor mount itself, what you see on the left is the current generation of the motor mount. What you see on the right are the 2019 versions. So you can see a lot of work has gone into not just optimizing it from a weight perspective, but also a lot of improvements in the strengthening of the motor mount itself. So today, we've been through, I think, about 3-4 years of analysis from the first generation of the motor mount to what you have now. from every sort of use case, every load case. Of course, moving along, we'll get into our testing protocols and a lot of testing that's happened off the roads as well. And what we have now is a motor mount that is on the frame that is 30% lighter and 2 times stiffer as well. So putting this on paper, I mean, is one thing, but we are talking about easily 8 to 10 months of minute refinement that went in to make this happen. So all of this did not happen just on CAD or on paper. Of course, that was the, beginning process of the design stage. But then we have a really large testing team as well that gives us day-to-day data on the handling of the bike in various condition situations. That data goes back to our R&D, the tweaks are made, then the next prototypes are made. So this was a back and forth loop between design, engineering, and testing for that period of over 10 months till we reach the right strength and stiffness qualities that we wanted. Now, the next part is the transmission. So this will lead to the question of, are EVs silent, or could they have a sound that defines the identity of electric vehicles? That was one aspect. The second for us was the durability of the transmission itself. So we have a step-down transmission within the motor mount. What you see on the right is the older generation, 2019. That did its job functionally perfect, but we had some issues with the durability over, we are owning motorcycles for between 7 to 10 years, right? That's what we are aiming to design for. So from that perspective, it was important that we refine it. The second that I mentioned was the sound as well. So sound had some amount of coarseness back in 2019, that a lot of it had to do with the gear meshing. Now that, if you look at what's happened on the right side, of course, like again, we can talk endlessly about the simulations and testing that has gone in. If you look at this, this is a real world representation of the older generation gearbox and the new transmission. So you can see the details when I speak about the simulation, right? We are getting into gear teeth profile. We're talking about the gear meshing angles. We're talking about the number of gears on the driving and the driven gear. So all of this goes through months and months of validation on CAD, build it out, test it out on the roads. When everything starts to align together is when we finally freeze the requirements here. Now, the other aspect that I think took us a lot of time and testing to get in place was design for production. So making a part for a prototype is, I wouldn't say simple, but it's relatively simple compared to mass production. Some of the components on the 2019 generation ran milled swing arm, milled triple clamps, milled lower tees as well. So all of this now going from a milling process where you're using a block of metal and carving a form out of it is a process that involves molten metal flowing into the whole casting process and then giving you the exact same desired strength and qualities. So the swing arm was another aspect where a lot of analysis testing went in. This swing arm was doing its job, but what we felt or what the testing team came back to us and told us, or what you probably would tell us when you ride the bikes, is the right characteristics in terms of the handling, the strength, the stiffness. All of that had a lot that could be improved from this point. So 2019 all the way to 2022. Now you see the complexity that has gone into, what we could perceive as a simple functional part like a box section swing arm, made more complex by our necessity to pass the chain through the swing arm itself. So what you see here is what is going out today on the production version. And yeah, it's a work of art, the swing arm, and all of us love it. Moving on to vehicle testing, this has been a standard part of our protocol for the last 3 years. 4 types of testing. One is what you see on top is everyday real world testing. Today, we have multiple bikes doing a few hundreds of kilometers on the road every day. More than a testing point, it's more of a data logging point for us in terms of fine-tuning the algorithms. Second, of course, when you push the motors, the batteries to the peak requirements and figure out how that whole modulation can happen, right? That happens on racetracks, it happens on the runways. Third, coming to uphill riding. For any sort of vehicle, IC engine, EVs, whatever it be, overloading a vehicle going up a hill on a hot summer afternoon probably represents one of the worst usage conditions. So how do we figure out that all of our systems are safe, robust, and able to give you the exact part that you need without any drop in performance under most of these situations was what came in from here. Then, of course, a lot of suspension and brake and ABS tuning happened at various facilities in collaboration with our partners, torture tracks, ABS tuning tracks. So this again happened more recently, I think towards the early first half of 2020 is when we froze on all of these requirements as well. Now coming to, I think one of the underlying themes for today, the bare maximum, right? So all of the previous testing protocols process that you see sort of encompasses everything that a vehicle needs before you can put it out on the road. But all of us in the company are hardcore motorcycle enthusiasts. I've probably owned 5 motorcycles through my years before we started Ultraviolette. Neeraj probably 3 or 4.
Yep.
And every single member is crazy about motorcycles. And one underlying theme is we want to be free, we want to be wild, we want to be impulsive, right? Now, just because it's an electric does not mean you take away all of these aspects. So how do we make sure all of that is captured and, planned for, and the software is tuned for these requirements, was a monthly campaign called Beyond Asphalt. So this is something we do. The theme is electric is capable of any sort of use and abuse that you can throw at it. And that's what we at Ultraviolette are designing for.
So one of the things that I think generally electric vehicles are perceived as very delicate vehicles, right? And this sort of effort that we did was meant to overcome that limitation that is perceived when it comes to EVs. And we wanted to know this for ourselves as well. In fact, some of the visuals that you see here, they're quite extreme in terms of the conditions because there's only so much you can do in terms of simulation or engineering. You really have to push it to its limit, to its breaking point to see what that breaking point is, right? And so what you see after this is part of that campaign. And it was sort of validation for us as well that when these kinds of extreme scenarios are presented to, a bike is pushed into these scenarios, is the frame, is the battery pack, is the software going to survive? Is it going to be, if the wheels are not in contact with the surface, does that make a difference? Is the handling affected? Is the suspension affected? Is the chassis capable of withstanding this kind of extreme use case, right? So I think you'll get a sense of that. Cool. I think the idea here is that, while it's a sports motorcycle, it's an urban sports motorcycle, what can we really push this bike to its, to see its breaking point? And that's one of the efforts that we did. In fact, while Narayan and the team were, conducting these activities back in our R&D center where we're getting all of the data, there was a constant concern, right? Are these guys going to break the bikes? Will it come back in one piece? And
I mean, one thing is the cool visuals that we see, but back end every night there was a download of data. The team back at R&D was going through all of the data, telling us, what they could tweak to offer or solve a problem. And this happened on a monthly basis for the last, I'd say, 4 or 5 months.
Yep.
And has helped us address a lot of the edge cases that you might not face on a everyday road riding condition. And that was the intent backend. And of course, communicating that what we're building is for any and every sort of use case was very important as well. So talking about the data, I'll probably get into a little more context to how real-time connected all of our systems are.
Yeah, so this is where I think we're quite different from several companies that way, which is that the data that is being generated from these vehicles is very critical to us, more so from an engineering standpoint, from validation, and to ensure that every bike that is out there is performing up to its actual abilities, right? In terms of the data that we collect, I think for us we get a ton of information from the voltages, the temperatures. So what you see is basically we're getting constant information from the vehicles in real time. All of these vehicles have eSIM cards with LTE connectivity, and we're constantly getting information from multiple redundant sensors on the battery packs on the vehicles. We know how much energy is going in, from the battery pack to the vehicle electronics to the motor controller and finally to the wheel as well, right? So this is something that we capture and we analyze in either in real time or through batch analytics, and we use that information. So this is what in terms of roll pitch yaw information, in terms of lean angles, this is also data that is being captured in real time, right? So even in fact what we can see in the data is the suspension travel, right? We're able to see it from the pitch information on the vehicle on the vehicles that this is being done on. So that's the kind of data that we're collecting. There's a ton of it that we use internally. Of course, this is too much information in some context, but it's very important for us.
Right now, evaluating what way and form it comes to the rider as a tangible form of data that helps maybe everyday riding. But I think a lot of what we saw here could be used in a track application as well, where you do a bunch of laps, you get all your data, then you figure out what you could do differently, get on the track again, and multiple use cases that we are foreseeing with the sort of real-time connected experience here.
Yep. Coming to the next part, right? So I think this is what everyone's sort of been waiting for. This is the major update in terms of what we've been working on. It has to do with the batteries, right?
And I think all of what we spoke about, the batteries have had a very strong bearing on that, whether we're riding in off-road conditions, raining, high levels of water, rain, bad weather, slush, marsh. Of course, we're monitoring what's happening on the control of the motor, etc. But the BMS and the batteries being able to modulate performance, figure out what's happening within the battery, outside of the battery with the other correlated systems, and enough levels of safety being provided was extremely important for us. And
so here we are talking about the power modules of the future. Here, this is where the maximum amount of effort was put in to leapfrog one entire generation of the battery architecture, right? In terms of, I think, yeah, let's play the video.
So what you just saw was our production final generation of the power module 2.0. And We have the battery pack here as well. It's going to be here in case you want a closer look at a later point. And this is, for sure, the largest battery pack on two wheels in India, right?
Yep.
And we'll get into a lot more details of how we've gone about it. Very fair to say that we have spent as much time engineering the batteries as we have on the vehicle itself. And there has been aerospace technology going into it, consumer electronics, and of course, automotive. And all of these three domains coming together is what you see right here on the F-77 battery packs.
So we'll elaborate a little more in terms of what we're talking about when we're talking about the updates on the battery, right? So this is one major change that happened was in terms of the form factor of the cells itself, we had seen the industry also progressing towards this direction, which is, a change in the form factor of the cylindrical cells from 18650 to, 2170 or 21700 as then.
So this was one more thing that we had earlier thought we do in 2024, is what we fast-tracked in 2019-20 during that time.
Yeah, so more critical than this was another piece of, information that we started to sort of get from consumers, from our test rides, right? In terms of, we had these modular batteries, they were amazing, the 9 kilos, very high power density, very high energy density, but then
the flip side was we were maxed out at about 140, 150 kilometers of range. And maybe for some other form factors of vehicles, that's a good number. But for motorcycling, not only are we talking about everyday riding in the city, I think important for us to sort of account for, the intercity travel and, of course, your adventure requirements on a weekend as well, right? So a lot of going back to the drawing board happened, and what you see is a result of that. We'll get to the final specs and numbers.
Yep. So this was a sort of important change because it sort of meant, the vehicle architecture improves. Obviously, because of the size of the battery pack, we're talking about the largest battery pack on any sort of electric vehicle and motorcycle in India, right? So we had to accommodate this requirement. We'll come to details on the range specifically a little later, but let's talk about, what this means from, one important aspect of, lithium-ion batteries, right, which is around the safety, right? So we have, the way we put it is we have 5 levels of safety, right? One is from a software safety standpoint, right? We have protections that are kicking in, in microseconds to milliseconds. So how do you coordinate all of these protection mechanisms, right? You have current interrupt devices on the cells, you have, cell level protections such as cell level fuses, you have a module or pack level fuses, you have, MOSFET protection and, at an electronic system level, but all of these need to work in a coordinated fashion, right? Because some of them can kick in microseconds, some of them, like slow blow fuses take, up to a second, and some are in a few hundred milliseconds. So making sure that all of these are working in a coordinated manner was sort of very critical to, building out these batteries, right? And the larger the size of the packs, the more cells in parallel, the higher the energy density, the more critical this becomes. So having this, while we had parts of this figured out for modular batteries, now going to a much larger size battery pack meant, we had to revisit and go through all of this all over again, right? The other aspect of this is from an electronic safety standpoint, right? Now, this is where the battery management system comes in, right? This is where there are redundant electronic circuits. This is where, what Narayan was talking about, sort of the avionics approach comes in, where we're talking about electronic systems where there are redundant mechanisms to take over in case one system doesn't do the job, right? So in terms of specifically the BMS itself, all the way from 2016 to 2021, there were, several changes that happened, right? Now, while this is a lot of detail, but for us, essentially this meant that, there'd been improvements in the microcontrollers, the microprocessors that were being used, the different kinds of overvoltage protection, your failover mechanisms, we had to sort of bring in pre-discharge, mechanisms to prevent, any kind of sudden, sparks and things like that. So we had to protect other systems on the vehicle as well and protect the battery pack itself. And then it wasn't just Indian standards that, we're building for, right? We are actually building these motorcycles, they're made in India, but they're for the world, right? Which meant that these electronic systems needed to cater to global standards, and that's where, 2271, 2580 comes in, right? And we had to have redundant hardware just to support these requirements, right? So all of these things started to come in. One major change was even when we talk about short circuit protection, right? Now, all battery packs have short circuit protection, right? But how fast does it kick in? And when it kicks in, how much, every time you run these tests, you sort of tend to degrade these batteries. So the faster you're able to enable this, so we went from a few hundred milliseconds to, tens of microseconds. And that's the kind of improvement that we saw over the years. And that's something that has come into this battery pack, right? In addition to the electronic systems, we talk about electrical safety. Now this is coming into from the point of view of, passive elements, mechanical elements that form electrical circuits, fuses. We're one of the only few companies globally that has mechanisms that are protecting, the battery packs and individual cells from any sort of failure, where we're able to isolate cells if there's a defect or a failure of any sort that occurs, right? So this is from an electrical safety point of view, right? Then we come to sort of a very critical aspect when it comes to lithium-ion batteries, right, which is the thermals of these batteries. How are they managed? Because they have very narrow operating ranges when it comes to temperatures, right? So how do you maintain the evenness of temperatures across the battery pack, irrespective of the size, shape, something closer to the enclosure wall versus something that is in the center of the battery, right? How do we maintain that distribution? And this becomes even more critical when we are talking about higher currents, higher power levels, right? You're not talking about, 3 kilowatts or 6 kilowatts like, most of the EVs in the market. Here we are talking about in the range of 20 kilowatts, 50 kilowatts, right? So how do we enable even, thermal distribution? How do we ensure that what we're putting out there, because one of the other things that comes up when it comes to thermals is that if there is uneven distribution of temperatures across the batteries, that leads to uneven degradation, and your cells become the single point of failure, right? The cells which are degrading faster. So this is something that we again had to rework. It was a sort of major leap forward. In fact, what you see here today, and in terms of the battery pack and the vehicle, it's unlikely that you will see any competition for the next 2 years. That's going to be my claim, right? You guys can test that out in the real world. We'll see when there's competition, because essentially it finally boils down to the thermals on the batteries, right? And that's where we've leapfrogged the entire generation. And it doesn't end here, right? We're talking about, wind tunnel tests to prove that, can this heat which is removed from the cells, so the cells themselves generate heat, they're extracted to the enclosure walls, and from the enclosure walls, they're dissipated out to the, ambient air itself. And so how do we
think if you get a closer look at this, you'll see the entire casing is aluminum, which is very, very robust and strong from a mechanical standpoint. And there's multiple zones of heat removal plus strengthening on the battery pack itself.
Yeah, and that sort of brings up the next point, right, which is mechanical safety. Now, these battery packs are intended to withstand very, very high levels of shock, impact, any kind of vibration. And that's where the sort of aluminum enclosure comes into picture. They're sort of, explosion-proof batteries. They're sort of, and this is completely fully aluminum that we put together for these battery packs to ensure that, right? I think then we have an important topic to talk about.
I think very pertinent. One of the topics for the evening, what is the range improvement that we've got into? When we started the company in 2016, our assumption was, is 100 kilometers okay? 3 digits seems a fair assumption. Average riding was about 25, 30 kilometers a day. I think by the time we got to 2019, we had progressed to 150. And when we took this 1 year to just like relook at the battery, the range, the riding behaviors, and of course all of the inbound questions about how can we increase further range is what the whole point was in getting from 150 to the next advanced stage. You'll see that here. So this was the immediate target for us, and I think about sometime early this year, we were at 200, and the next 8 months went into further pushing this, we weren't happy. Like, what can we max it out to? And here goes. Yes, so that is where we are at as of 1 week back. And for us as a company, it's going to be an ongoing endeavor in terms of seeing how we can push the boundaries of technology, and of course, range is a very critical part of that. Multiple things go into a good riding ownership experience, predictable and enough and more range on the vehicle, and of course, ease of availing energy on the go as well. So we've sort of tackled both of these, and I think by now we have spoken enough in theory. And coming back to the point there of, if you could all turn right, we have the production-ready naked motorcycle version of the F77 out here. So this is, I mean, we're providing a tribute to Imagine, Design, and Make in India. And I think let's all put our hands together, inspire a lot more people to get into the whole hardware ecosystem, to get into motorcycling, and see where we can collectively push the industry towards. So yes, I think we can unveil what the final specs of the bike are. Check? Yeah. So that is something we are extremely proud of. That often goes unnoticed, the amount of engineering, R&D, and effort that goes into giving an uncompromising experience. Right? We've all got a fair idea of what the bike looks like, and I think this today is a tribute to the entire engineering community to make this happen. It's been a great 5 years of exciting times. It's been a lot of despair. It's been a lot of figuring out how to solve technical problems, operational issues, and we are super happy to be presenting this to you today. And one of the questions that I think we are bombarded with on a daily basis, when can I pre-book the F77? And that starts on 23rd October, which is less than a week from now.
I think we can have a sort of Q&A session now. Also like to call up.
I mean, just want to wind it up by thanking our team. I think a lot of our team is here today. In case you want to interact with any of us, all of us are here. And thank all of you for being here. Of course, we'll get into a detailed discussion post this. And to everybody who's watching this on YouTube, following us for the last 5 years, we've got some very, very strong supporters out there. Welcome to the future.